Okay, so we're going to talk about the correlation coefficient. And right now we're just going to talk about some properties of it and some things to go along with it. And then in the couple of videos following this, we'll talk about how to actually compute it. Okay, so what the correlation coefficient does is it's going to tell us two things. One, it's going to tell us which direction, whether it's positively or negatively associated. And two, it's going to tell us how strong of a relationship there is or association there is between these. Okay, so there are two formulas here. We have one of them, they do use the letter R for this. Okay, and so one of them utilizes finding the mean and the standard deviation of the X values and the mean and the standard deviation of the Y values. And then, as we've seen before, there's always kind of the prettier looking one, and there's one that looks a little more complicated, but actually is a little bit easier to calculate with. And so that's what I've got down here at the shortcut down here at the bottom. We're going to be utilizing the number of values that we have, or the number of pairs that we have. We're going to be multiplying some values together, and then we'll be squaring and totaling some stuff up as we go through. But more on that in a later video. Okay. So a couple of things that we need to know. This value is always going to come out between -1 and 1 inclusively. So it can be as far as -1, it can be as high as +1. And that positive or negative, the only thing that tells us is whether or not it is a positively associated or a negatively associated. So if the answer is negative, then it was negatively associated. If it was positive, then it was positively associated. Okay. The other thing is that if just looking at the numeric part of it, not the positive or the negative part, but just looking at the decimal part of it, the higher that value is, the more linear or the more straight line it's becoming. Okay. Now, the other things about correlation coefficient is it does not depend on the units. So if you're measuring in minutes and you ran it again and you measured in hours, or you were measuring miles and you did something else in feet, it does not change the correlation coefficient. They would both scenarios would have the exact same correlation coefficient. It also does not matter which variable is X and which variable is Y. Now, we don't traditionally go switching those up, but it doesn't matter. Okay, so we do have a little bit of freedom there. Now, this correlation coefficient will only check for a linear relationship. Okay, so if we get that it is not a very strong linear relationship, it's actually two scenarios. One is there is no association whatsoever. The other one is that there is some sort of other association type. Okay, so what I mean by that is when we talk about this linear correlation is going to try and tell me how good of a line pattern I have. Okay. So both of these would have positive association. This one's correlation coefficient, this is probably going to be something like 0.99. Okay, it's really strong because that's almost exactly in a straight line. If it was a 1, it would be perfect. Now, this one may be something like a 0.7. Okay, there's a pretty good straight line going through there, and I can kind of see what's going on. Now, if we get a low correlation coefficient, okay, something that's really close to 0, we may have something that's like this. Okay, there's not really a linear pattern there. It literally just looks like stuff on a page. Now, the other thing though is if I have another shape that is a U shape, or maybe it's some other sort of a curved shape, these will also have very low correlation coefficients, linear correlation coefficients, because you're trying to put a line against a curve. It's going to say this is a really bad line, because if it tried to go this way, all of these dots tend to mess up that patterning. If this one tried to do something through here, all of these dots are messing it up. Okay, so when we look at stuff like this, okay, we have to remember that this is only going to talk to us about a linear relationship and not any other shapes. Okay, there are other formulas for other shapes. We don't have to worry about those for this class. We only have to focus on linear. Now, this correlation coefficient, this calculation, is sensitive to outliers. And we've talked about outliers before, those really high or really low values. So those dots, if you have one, can bring and can drastically change a correlation coefficient. So something where you had several dots that were nice and clean and pretty. So going back to kind of some picture ideas here, if I had, you know, something like this that was pretty good, strong thing, so that was like a 0.8. But then I had almost that exact same setup, okay? But I had a couple of dots down here. All of a sudden, these two out of ordering dots that aren't fitting in the rest of the pattern can all of a sudden drastically drop something that had a pretty good pattern, okay? We're getting up there in our value to something that's a little bit lower. Now, we're not still saying that there's not a good linear shot there, but these dots are tending to mess that up, okay? So, a couple of other things that we want to look at, okay, is that if R is positive, then it has a positive linear association, okay? It's nice and clean, it tells us that. If R is negative, then it has a negative linear association. And I've kind of already hinted at this. If the value of R, don't look at the positive or negative, just look at the numbers part. If it's close to 0, then there's not a real strong linear association. We typically kind of bundle them. 0, 0.1, 0.2, 0.3 is all kind of weak. We're going with there's not really anything there. You're really kind of reaching for stuff to, you know, there's just not a whole lot there. You get into your middle numbers, your 0.4s, your 0.5s, your 0.6s. We're starting to get someplace, okay? There may be kind of a rough idea of what's going on there. And when you get up into those upper ones, 0.7s, 0.8s, especially the 0.9s type stuff, then you're starting to get a stronger association. And those dots are really starting to, you know, lay down in a nice, pretty line. Now, the closer you are to 1, the more a strong positive. And again, the negative is going to just put it into a negative association. Now, if you happen to get 1 or -1 spot on, then it is a perfect linear association. Put a ruler on it, you're going to hit every single dot, okay? That is absolutely, you know, perfect precision. We love those. Do they have a lot? No. Now, one of the things, though, that we need to discuss about correlation coefficient, which is wonderful, is that it is providing a measure of the association between two things. We talked about the square footage of the house and the price of the house, okay? But what we can't do here is correlation does not equate to causation, okay? Just because I say two things are associated with each other and I see a pattern there does not mean that one causes the other one to happen, okay? So they give the example. We got a group of elementary school kids, they took a vocabulary test. We looked at also their shoe sizes, okay? And so we happened to notice that the kids who had larger shoe sizes got higher scores on the test, and those that had smaller shoe sizes got lower scores. As a result, we decided, and we were able to make a positive correlation between shoe size. As shoe size got bigger, their scores got higher. Now, does that mean that if I have a large foot, I am the next genius and I am the next Albert Einstein? No. Okay, so this is one of those things that just because we make a connection between two things does not mean that we've created a cause and effect relationship. Okay, the only way you're going to be able to create or determine a cause and effect relationship is if you do an experiment. Okay, so we can talk about that the two things are connected, they're associated, they are correlated with each other, but we cannot then say that one makes the other one happen or that we are in a cause and effect relationship.